Alright, hi everybody. I'm going to do a quick lesson on finding the density of objects. I want to be real clear about something. Just knowing how to find the density of something does not mean you actually understand the word density. That's something that we're trying to work on as we investigate density. We're figuring out the mass and the volume of objects, and we're collecting a lot of data, which you can see over here. And that data will be used to kind of further our investigation of how do things float and why do they float. We know it has something to do with mass, and we know it has something to do with volume, and those two things are part of density, and so that's what we're trying to figure out. So this is just a little mini lesson on how we find mass and volume of different objects, and also some quick notes on density. First of all, density is mass divided by volume, and kind of a word definition for density is how compact something is. The volume is the amount of space something takes up. The easy way to find the volume of a cube is to take length times width times height. That would work with anything that's a rectangle type shape. You can also find the volume using the displacement method. A lot of you probably remember that as the dunking method. It's where we put things underwater and see how much the water goes up. And then density or volume is measured in milliliters or centimeters cubed. The mass is how much stuff something is made out of. I want to remind you that mass is not the same as weight, and we measure mass in grams. The two objects that we're going to find the density of today are this blue square rectangle object and this rock. We're going to start with the rectangle. And so I take my ruler, and first I'm going to measure the height, which this is about 0.6 centimeters. So I'm going to write that down. So 0.6 centimeters, I'm going to take that times the length, which is about 2.1 centimeters. 0.1 centimeters. And take that times the width, which is about 3.1, which that makes me think that the height was 3.1, which when I go back and check, it is 3.1, not 2.1. So it's always good to check your work, times 3.1 centimeters, and that equals, take my calculator out, 0.6 times 3.1 times 3.1 equals 5.766, so I'm just going to say 5.8. 5.8 centimeters cubed, which is also 5.8 milliliters. Alright, now I got to go find the mass of this object, which I come over here to one of our scales, and the scale says 0, so I don't need to do anything with it, and it's on grams. Oh, got to make sure it says 0. Put my object on there. It is 4.8 grams. 4.8 grams. Write that down for my mass. 4.8 grams. Now I know that density equals grams divided by milliliters, so that equals 4.8 grams divided by 5.8 milliliters. Put that in my calculator. 4.8 divided by 5.8 equals 0.83. So 0.83 grams per milliliter. That is my density of the blue object. Now the rock is a little bit more difficult. I can find the mass pretty easily. I'll draw a line on my scratch paper here. The rock is a little bit more difficult. I can find the mass of the rock pretty easily just by putting it on the scale again, which now does not say, oh, it does say 0.0, oh, 0.1. Just hit the 0 button, put my rock on there. My rock is 13.7 grams. So I'm going to write 13.7 grams. Now I got to divide that by my volume. So we got to find the volume of the rock. Now, this is where the water displacement method comes in handy. Alright, I get down and I read, this is a graduated cylinder. I get down and I read the volume, and remember I read the bottom of the meniscus, which is the thick line, and right now it's right at 30. So now I'm not going to just drop this in, I'm going to put it at an angle and slide it in, because I don't want to splash the water. And now it was at 30, and now it's gone up to 35. And so it started at 30 milliliters. It went up to 35 milliliters. And so my rock's volume is 5 milliliters. Now I take my mass divided by my volume. So 13.7 divided by 5 equals 2.74 grams per milliliter, and that is my density of my rock. Notice the density of the little square plastic piece is very, very small when I compare it to the density of the rock, which those of you who have worked with the little plastic piece, you know that this will float, whereas the rock obviously sinks. And so perhaps the differences in density can help us understand the differences in the sinking and floating. That's something we'll talk about in the future.